Hey everyone, and welcome to the Explainer. Today we're diving into something absolutely fascinating, Phygital realization and the SeedTree DB. We're going to unpack this whole, often misunderstood bridge between deterministic digital states and physical hardware execution. I mean, we hear a ton about smart contracts in blockchain, right? But what actually happens when that perfectly verified digital code needs to, say, turn on a light, move a physical motor, or dispense an item in the real world? Well, translating on-chain data to physical edge devices historically, it's pretty chaotic. Usually developers rely on traditional event-driven programming. But, when you're dealing with distributed ledgers communicating with physical machines, it's kind of like setting up a massive, complex game of dominoes, where a single breeze just ruins the whole sequence. A signal might get delayed, an event fires twice, or the hardware state just falls completely out of sync with the digital ledger. So how do we actually build a flawless bridge? To get there, we'll follow this roadmap. First, the digital-physical divide. Second, the 0 to 1 experiment. Third, scripts as databases. Fourth, the syn kernel function. And finally, Phygital edge execution. All right, let's kick things off with Section 1, the digital-physical divide. And this brings us right to the CheerBot. Look at this thing. It's an IRL toy robot that basically acts as a physical switchboard. You see, instead of relying on those incredibly complex, heavy Ricardian contracts that try to bake all these dense legal parameters directly into the code, CheerBot bypasses that 30-year technical wall entirely. It connects a really simple on-chain JSON callback directly to the physical GPIO pins on a Raspberry Pi. Why? To spread cosmolocal cheer, literally reacting physically to digital tips or NFT ownership. It's a real game changer. Moving right along to Section 2, CheerBot, a 0 to 1 experiment. Now, it is absolutely critical that we frame this correctly. CheerBot is an experimental 0 to 1 proof of concept. The creators explicitly point out that they're splitting off this lab portion from any 1 to 100 scaling efforts. So this isn't some mass market retail product you're going to buy off a shelf. It's an experimental foundation, a true sandbox for physical automation literacy. So, you might be wondering, why did it stay a lab experiment? Well, because of what's called a temporal fracture. See, back in 2022, the infrastructure for this bot relied on a concept called web monetization to handle the micropayments controlling the Raspberry Pi. But when the primary provider for that, a company called Coil, collapsed, the project's economic engine basically failed to achieve mass adoption. Fast forward to 2026, and the project purposefully remains a pure 0 to 1 proof of concept. They're totally focused on proving the technology works, rather than chasing commercial scale. But despite that economic fracture, the physical hardware realizations of this lab are just fascinating. We actually have two distinct iterations here. On the left, you've got the boombox economy build. This is a 3D printed, highly accessible unit that's totally ready for basic Web3 smart home integration. And on the right, there's the premium Ethbot limited edition, which is more of a high-end designer toy wrapped up in deep Web3 lore. But here's the thing. Both of them serve the exact same foundational purpose, which is flawlessly bridging a digital wallet directly to a physical space. Okay, on to Section 3, Scripts as Databases mission. To make the CheerBot work as flawlessly as it does, the team had to completely rethink how data is handled. And that led to the Scripts as Databases mission. Think of it like this. They basically married the rigid, predictable structural order of a traditional database with the dynamic executable change logic of a script. By embedding live function objects directly into the database tree structures, they literally eliminated those messy event-driven scope and timing issues entirely. So as you can see, we're basically trading the total chaos of traditional event-driven programming on the left for this deterministic elegance on the right. And they achieve this using an on-chain LIFO, or last in, first out, JSON state tree. Because it processes the most recent command first through a single entry point and mathematically verifies the state before moving forward, there's zero ambiguity. The state is either true or it isn't. No in-betweens. That brings us to Section 4. The syn kernel function. At the absolute core of all that logic is the syn kernel function. Syn stands for thesis, antithesis, synthesis, and it essentially acts as a strict logical bouncer for the database. Here's how it works. Step 1, it checks if a space in the database is empty, a null value. If it is, boom. Step 2, it synthesizes the new data right into that slot. But if data already exists there, the bouncer rejects the input. That is, unless you explicitly use an option flag to override that namespace in step 3. So it sequentially checks for space and resolves conflicts before a single byte of data is ever written. It's brilliant. Now, the CheerBot Demo Day walkthrough demonstrates this behavior perfectly. It shows exactly how the SeedTree DB completely eliminates those event-driven scope issues we talked about earlier. The system burrows into specific branches to execute functions, and it relies on incredibly strict schema validation. For example, if a user tries to input a text string into a field that specifically demands a number, the database just outright rejects it, no exceptions. It safely isolates and updates localized variables, and then deterministically calculates the output. This ensures absolute fidelity, meaning zero logic misalignments, simply because the data is perfectly parsed before execution. Which leads us to our final part, Section 5, Phygital Edge Execution. Now we reach what's called leaf node logistics, mapping those flawlessly verified digital states directly to the physical edge. In this specific case, the whole thing happens on a local internet. The Raspberry Pi inside the CheerBot reads that mathematically pure JSON state tree we just discussed, and it simply triggers the corresponding GPIO pins to display a graphic or move a motor. It is just a direct, uncomplicated translation of digital truth right into physical action. And this brings us to such a beautiful concept, the semiotic bridge. Imagine a human pilot applying their intent, say, deciding to tip a creator. That intent is processed through a deterministic scripter, which is referred to in the architecture as the polycrotus agentic cell. Think of it as the uncompromising brain of the entire operation. It literally translates your imagination into pure logic, bending the hardware to human will without any chance of catastrophic mistranslation. So I want to leave you with this final thought to ponder. We're looking at a system that completely bypasses decades-old technical walls simply by marrying the structural order of a database with the execution of a script right at the physical edge. As these 0-to-1 labs successfully map flawless on-chain authorship to our physical reality, a brand new literacy is being born. As machines increasingly rely on these deterministic semiotic bridges to take physical action right in your living room, well, the question is, are you ready for the era of Phygital automation literacy?